Well, so far when sequencing, we've been recording directly to the linear phrase tracks. Now, some people will prefer to work in a different way. It's possible to record into patterns, and each song contains 100 patterns. Okay, well, there's the main sequencer display. To get into pattern record, press this button here, marked pattern. And you can see pattern numbers are shown, and there are 100 patterns within each song stored with the song. And you can name your patterns as well. So the idea is you can create songs by chaining together a series of different patterns, much like working with a traditional drum machine, only, of course, in this case, we can record all 16 MIDI channels of information to each pattern. So I've named 4 patterns here: drums, piano, bass, and synth. And they're just simple 4-bar loops. Let's have a listen. There's the drums. Let's try number 2, piano part. Number 3 is the bass. And finally, the synth sound. Well, I can put these patterns together to form a song, but I'm not too sure how I want to do that at this point. I'd like to experiment a bit. There's a very handy feature called real-time phrase sequencing, which allows me to assign each of those patterns to a separate key across the keyboard. So this is what we're going to do. We're going to go to F1, Setup. Press it once and look for RPS. If it's not selected, then press F4. And the display shows a key name, in this case C2, and it will change depending on the key you play. Now, let's assign pattern 1, the drum pattern, to that key. Play the key. Well, still nothing happens. Well, that's because we're not actually in RPS mode. To do that, we switch the RPS button over here on. And now I should be able to directly trigger that drum loop from this key. Well, that works really well. So let's assign some of the other keys. The next key up to the piano part. Next key up, bass part. And finally, synth. Okay, well, you may notice down here we've got various playback modes. Loop 1 will loop the pattern once it reaches the end of the pattern. And it's dependent on whether I hold the key down or not. Loop 2 will simply trigger from the key, start, stop, start, stop. Down here we can set up mute groups. This simply determines a group. Any 2 patterns within that group cannot be sounded at the same time. So I'm going to leave that off for the time being. And here we have trigger quantize. Well, okay, at the moment, each of the loops will trigger as soon as I play the keyboard, just like triggering samples from a sampler. But I could set up a real-time quantize so that the loop will only trigger when I reach the next beat or the next measure. So that automatically puts everything in time. So let's leave that on beat for the time being. And I can now try an arrangement using my 4 patterns. Let's see how it works. Let's try adding the synth. Bass. Piano. And finally, all 4. Well, once you're happy with your real-time phrase sequencing, you can choose to record the overall performance into the sequencer. So let's do that. Back to sequencer mode. Make sure that the RPS light is still on, however. Record ready. Select the track you want to record onto, and in this case I've given myself a 1-bar count-in rather than the usual wait for note. So let's start recording. And that's my performance recorded. Rewind, playback. And you'll notice that if I switch off RPS at this point, it has no effect on the sound, because what I've recorded is the note information that RPS created, rather than the RPS itself. The XP-80 contains an incredibly powerful synthesis engine, and this is able to control the sounds of the 4 tones within a patch completely independently. And we can set up completely different parameters for each tone. We can view the information in 2 different ways, however. Okay, user 001, patch West Coast. Let's go into the wave generator, F2, and then WG parameters. Now, this displays the associated parameters for tone 1. And that's everything I need to know in this section on the display. However, if I want, I can go to the Edit palette down here, F6, and view the same information in a different way. This time, the parameters for all 4 tones are displayed on the screen, and the information runs downwards, and we can scroll down the display to access the extra parameters that now won't fit on the display because of the extra tones. This is particularly handy because it allows us to compare the data for each tone. Okay, well, to go back to the single tone view of the parameter settings, press F6 once again, and it takes us back to the currently selected tone, tone 1. Now, some of the controls have very, very nice graphical representations of the parameters. These will not appear if you're using the Edit palette mode. Okay, but if you view each tone independently, then you get the pictures, pitch envelope, so on. So let's now take a more detailed look at the various parameters available. The patch common parameters are those which are common to all 4 tones within the patch, so they're not adjusted separately for each tone, but globally. This particular patch, preset B84, let's go to F1 common, and let me explain each of these parameters in turn. Well, obviously the patch name can be adjusted. The patch level, okay, so adjust this to change the balance between this patch and the other patches in the machine. Patch pan, well, each of the 4 tones in the patch can be panned independently, but this is an overall pan, and it will bias each of those individual tone pans either left or right. Okay. Analog feel, this is interesting. Analog synthesizers of the past always had a component to the sound which was a randomness in terms of pitch and volume. This can be recreated, and it's particularly handy if you take 2 patches, identical, one with analog feel and one without, because they will modulate and phase next to one another, giving you a really, really thick sound. And the amount of analog feel can be adjusted. Okay. Bend range up, bend range down. Well, this is with respect to the pitch bend controller here. Bend range up controls how many semitones we get when we move the controller all the way to the maximum position. 2 semitones up, 12 semitones down. So the up and down ranges can be adjusted independent of one another. Octave shift, fairly obvious. Stretch tune depth. Well, this is not an often used parameter, but on certain piano sounds, it's sometimes nice to stretch the tuning. On a real piano, the high octaves are often slightly wider than the low octaves, giving a more consonant sound, and that can be simulated using the stretch tuning. Voice priority. Well, the XP-80 has 64 notes of polyphony, which means that, in fact, 64 tones can be played at any one time. Now, you can imagine in performance mode, when you're layering many, many patches together, it's possible to run out of available tones or available polyphony. In the event of running out, this is where we define what happens. We can prioritize for either the loudest note or the last note played, meaning that those notes will never be chopped off. Clock source. Well, each patch can have modulation effects, low frequency oscillators, and even timed effects within the effects section. And these all need to be referenced from some kind of synchronizing control source. The patch, therefore, can have a tempo associated with it. In this case, the clock source is the patch's own tempo, or we can clock it from the sequencer. I'll show you how to do that later on in the hints and tips section. And then we can define the patch tempo. So this will govern the rate of all of the time-based controls within the patch. So that's patch common general. Now, when you're editing the tones of a patch, you must be aware of the structure of the tones. It's possible to change the way the tones work together. Let's have a look. F1, common, F3, structure, and the display shows two diagrams. Now, the tones are grouped. Tones 1 and 2 follow this structure. Tones 3 and 4 follow this structure. And at the moment, they're both set to the most simple structure available. But there are 10 structures to choose from, and by rotating the dial here, I can call them up. Okay, well, really what we have here is different wirings for the two tones. And various options are available. For example, this one here combines two filters and puts them in series, which means we can overemphasize the filter effect, giving a very, very strong filter characteristic. Over here we see a structure that uses a booster. The little B there stands for booster, and we can use this for creating distortion effects, great on guitar and organ. Here we have another structure. Structure 5 uses what's known as ring modulation. This can be introduced and can produce all sorts of weird harmonics that are reminiscent of metallic sounds or bell-like sounds. Okay? And then various wiring options for those components. And over here, exactly the same thing can be done with tones 3 and 4. So when you're programming, bear in mind that wiring the tones up in a different way can give you completely different results. Now, do you remember when we had a look earlier on at splitting the performance via the keyboard into two separate patches? Well, the same thing can be done with the patch. So let's go to key range on F4. And we can see exactly the same kind of diagram here is shown, but this time we specify the active range for each tone within the patch. So we can still create those split sounds, bass, piano and so on, but this time confine the effect to within one patch. Okay? And it works in exactly the same way, exactly the same controls. Now take a listen to this sound. It's a steel guitar sound. So what's happening there? Well, I'm using what's known as a velocity split to switch between two separate tones. So let's go into patch common, velocity range, and have a look at the display. Well, it shows us here that tones 1, 3, and 4 are active. Tones 1 and 3 are simply left and right parts of a stereo guitar sound. And you can see here shown a black line for each of those tones and a velocity range, an active range if you like, of velocities 1 to 115 on each of those tones. That means if I play the key with velocity strength between 1 and 115, I will hear those tones. However, down here, tone 4 is the sound of the harmonic, and this tone will be active from velocity 116 to 127. So I'm only going to hear that if I play really hard. And you can see the line up here demonstrates this fact. Okay, so it's active for a very, very small range of the top of the velocity range. So that's how you can split the patch according to velocity. Each of the 4 tones in a patch are able to respond in some way to 3 patch controllers. Okay, what are the controllers? I'm talking about things like aftertouch, modulation, C1, C2, or maybe even the foot switches on the back here. Okay, well I've got a patch set up here, and I'm going to go to F3 control. Right, well we see here the common source. Now there are 3 of them, and number 1 is reserved for modulation, and we can use modulation to do a particular job to all 4 tones independently. But I'm going to show you how to set up aftertouch to control the cutoff frequency of the first 2 tones. So let's use common source number 2. First of all, select which controller you're going to use. You could use modulation, breath control, foot switches, whatever, but I'm looking for aftertouch. There we go. Now, aftertouch is pressure. As I push down on the keys, I can make some control change, but at the moment it's not doing anything. As I push down, it has no effect. So let's select edit for tones 1 and 2. So tone select 1 and 2. I'm going to choose the target parameter for this pair of tones. There we go, cutoff is what I'm looking for. And then the range of change. Let's go plus 30. So that should now operate the cutoff of the filter on tones 1 and 2. Let's try it. There we go, as I push down, the filter opens and closes. Let's now take a look at a tone-specific parameter, WG, wave generator, on F2. Now I've initialized this patch, so everything's working from scratch. A basic piano waveform. Let's take a look at these parameters. Well, that's the wave group. Two groups, internal A, internal B, with 255 waveforms to choose from in bank A and 193 in B. And as I said earlier, the B bank tends to be the rhythmic sounds, the percussion sounds. So I can select my wave from a list. And just as before, I can use the sound list to view the waveforms. Okay, let's just return that to the basic waveform number 1. I also have a booster here, wave gain. I can whack this right up, plus 12 dBs, which is really handy when creating distortion sounds, because I can boost the signal before I put it through the booster section in the tone structure, giving me lots of distortion. Over here we have a feature called FXM. This is a little bit like ring modulation, frequency cross modulation it's called, and it can help you create dirty sounds with lots of weird enharmonic overtones. And then down here we can specify a tone delay. You imagine the situation where you've created a patch using 4 different tones. You can specify a delay time for any of those tones, so that when you play a note you get maybe tone number 1, and then 50 milliseconds later you get tone number 2. So that's tone delay. Okay, well over here we can look at some pitch parameters, coarse tune, fine tune, random pitch depth. This is quite nice. It means that every time we play a note on the keyboard we can get a slightly different tuning from it. Pitch envelope. Well, this is interesting. Now let's just go over here and increase this to maximum. This is the envelope depth, and this is the amount that the envelope that's displayed here will control the pitch. And I can generate from here, as is shown on the graphical display, a pitch envelope, which means when I play the note it will follow the contours generated in the display. Let's increase the pitch level and the time. Play the note. You can hear that every time it's triggered, the pitch contour is followed, so it rises smoothly and then drops to a steady state pitch. And this is really handy for certain sounds like this one here, which is user 21. If you take a listen, 4 tones are used here, but each tone rises or moves down from the transient, giving a very interesting note-on sound. If we listen to each of those tones independently, using the tone switch, you can hear that one rises, that one falls, and that one's static. It's often useful on certain woodwind instruments because when the notes are played, often you get a pitch drop or a pitch rise on the transient of the note. So that's the pitch envelope. The XP-80 contains some very powerful filtering, and to access the filters we go to TVF. Okay. We see a display here. Now this is once again a graphical representation of the filter envelope. But first let's pick a filter, sound. We've got various types, low pass filter, band pass, high pass. And these are just different ways of emphasizing or de-emphasizing the frequency spectrum of a sound. Here's my basic sound. If I select a low pass filter, what I can do here is change the cutoff frequency of the filter, below which sounds will be allowed through, above which they will be attenuated. So let's reduce the cutoff frequency. Here, as I do that, the high frequencies disappear. I can increase the resonance of the filter, which is the intensity, and it will emphasize those frequencies just around the cutoff point. So let's boost, and you can see the graph shows me exactly what the filter curve looks like. And now we should have a much more intense sound, especially when I change the cutoff frequency. And that's exactly what we get. Now some of these other filter types are interesting. There's a band pass filter, which not only cuts frequencies above the cutoff point, but below it as well. But it has a band area where those frequencies are allowed through. This is particularly useful for wah-wah sounds and so on. High pass filter, which is exactly the opposite of low pass. And a new type called peaking filter, which has no effect on the sound at all, but it emphasizes a small defined region of sound. Okay, let's put that back to low pass for the time being. Over here we have resonance velocity sensitivity and cut-off key follow. Well, resonance velocity sensitivity just means that the harder you play, the more resonance you'll get from the filter. This is useful when trying to reproduce the sounds of acoustic instruments, where often, as notes are played harder, you get a more intense or emphasized high frequency range. And then the cut-off key follow means that the higher up the keyboard we go, the more filter we can introduce, the lower down, the less filter we can introduce, and so on. So that's the time variant filter. Each tone within the patch can also be processed by an amplitude envelope generator, or time variant amplifier, as Roland liked to call it. Now, take this sound, basic string sound, but using two tones panned left and right. Sounds good, but the attack time is not quite what I want. So one of the most frequently adjusted components is the attack portion of the envelope. I'll show you how you can do that then. F for TVA, and we're going to go from there to TVA envelope. Now remember, I said this was a two-tone patch, so when we make adjustments we need to adjust both tones at the same time, and that's easy to do. Down here where we see tone select, simply hold down the original tone and add the second, and you can see up in the display we see a 1 and an asterisk. We could process all four tones simultaneously, like that. A 1 followed by 3 asterisks, but I'm just going to go for the first two. So, 1, 2. Over here we see the time for the first portion of the curve. This is the attack time, and as I increase it, you can see that the attack portion of the curve increases at the same time. So let's now try the new attack envelope. Much slower. Slower still. Or I can reduce it all the way to 0. Exactly the same thing can be done with the release portion of the curve. Down here where this vertical line is drawn, this represents the note off event, and my release time can be generated in the same way. So let's really increase the release time to maximum. If I now play the chord, release it, the sound carries on playing for a much longer time. Each patch houses two independent low-frequency oscillators, and these can be used to control cyclically one of 4 parameters within the patch. Let's go and have a look into LFO F5. Now I've got my initialized sound back again. Basic piano waveform. Moving over here, I can control pitch, filter cutoff, level or pan from this waveform as shown. So let's generate pitch change or pitch modulation, otherwise known as vibrato. Okay, well I'm going to slow down the rate of the oscillator. I can also change the waveform. That's a triangular LFO. We've got sine wave, sawtooth, square wave. This is interesting, sample and hold. It's a kind of random LFO, but it works in steps, and it sounds particularly good if I speed up the rate. This, again, is a random waveform, but this time it moves smoothly. And we finally have a chaos waveform. Okay, well, let's put that back onto triangular. I can also target, other than pitch, amplitude, which will give me amplitude modulation, or otherwise known as tremolo. Or I can pan the sound according to the LFO, and I can even change the cutoff frequency of the filter, giving wah-wah effects. Okay, well, by combining all these different elements, we can create some very, very interesting sounding patches. Here's one which uses a combination of all these LFOs. User number 2. Each patch can contain its own effect setup, and to view the effects that are used, go to F6. And we want to look at the general layout under F1, and we see here a schematic. This represents the wiring of each tone through the effects network. So tone 1, in this case, is shown to have a send level to the reverb module of 51. 55 send level to chorus, and 127 send level to the mix master output bus. Okay, so this is, if you like, a balance between direct signal, chorus send, reverb send, and the output of the chorus and reverb modules can be set independently as well. So you can create a balance between the effects and the direct signal. Okay, well, you can choose whether the chorus is output directly to the mix bus or sent directly into the reverb unit. You can also choose the output type, whether in mix mode we're simply using reverb and chorus to the mix bus, or whether we incorporate the EFX module. In this case, the EFX type appears, and we can then select from one of 40 EFX effects. Okay, the send level of EFX to chorus can be adjusted, as well as to the main output. And we can even select for the outputs of the EFX module to go to the separate direct outputs on the rear of the XP-80. Okay. Now, the master reverb and chorus parameters are available down here. Reverb under F5, and here we can change the reverb type and the level, as well as a few other parameters associated with reverb. And this is global for all 4 tones, and exactly the same thing for chorus. Okay, level, rate, depth, and so on. Now, it's worth having a good listen to the 40 different EFX types available. They can really dramatically change the sound of a patch. This one, for example, user 98. It uses the distortion effect. Now, if I remove EFX, you can hear what a difference it makes. And let's take a look at the particular module that's been used. Effects, EFX number 3, distortion, is shown. Now, if you move to performance mode and call up the same patch, there could be a problem. As I've already explained, in the machine we have reverb processing, chorus, and 1 EFX type available at any one time. Since the performance mode is a collection of different patches which may all use different EFX, how can we possibly process all of the patches independently? Well, we can't. We have to choose 1 EFX settings for the performance. So let's go to performance mode and select for part 1 that sound. Well, you hear straight away that we've lost the EFX, but there is a remedy for this. Provided we just want to apply EFX to one sound, we can go back to the effects here, and this time specify EFX source. Well, at the moment this is set to performance, but if I set it to any one of the parts in my performance, it will draw the EFX settings from that patch. Okay, so for part 1, I'm going to use source. And now if I play the same sound, it has its original EFX intact. Have a listen to this patch, user 2. Now the LFOs are at work here giving us a rhythmic sound. If I stick it into a performance and try and record it along with the sequencer, I'll just start the metronome running. Play and you can hear that it runs out of time. So what we need to do is synchronize the LFO speed with the sequencer tempo. And to do that, we go to Performance Common and set the clock source from performance to sequencer. Back to sequencer, set the metronome going, and everything should stay nicely in time. And you can hear that it does. Okay, I've got a patch here, preset A46, it's an organ sound. And it's got a Leslie speaker simulator, and the speed of that simulation can be modified using the modulation wheel. Now, a lot of musicians like to have that kind of control from foot switch rather than from the modulation controller, so let me show you how you do it. This is the patch. We go to the effects section, F6, and then effects parameters are on F2, just next to general here. We can see the effects parameters for the Leslie, and next to this we have EFX control. Okay, EFX control number 1, well, we can assign 2 different controllers, but I'm going to select for control number 1, foot, for foot switch. But there are actually 4 foot switch controls on the back of the XP-80, so where else do we need to specify which of those 4 are going to be used? Well, it's in the system area, okay? Once again, F4 control, but this time from system, takes us to a display showing us the 4 pedals and the control assignment made to each one of those pedals. We can also specify whether the effect is simply internal or whether it's output via MIDI as well, okay? So what do? Pedal number 1, assigned to CC4 foot type. Well, let's check that I'm plugged into control pedal input number 1. I am, so that's good. Exit. Now we should find that the Leslie speed is controlled from the foot switch. On, off. Now, should you decide to use an external software-based sequencer, such as Steinberg's Cubase or eMagic's Logic, you'll need firstly to make the appropriate MIDI connections, MIDI in and out. Secondly, you'll need to turn the local switch within the XP-80 off. Now, as it stands, there is internal communication between the keyboard and sound source, but this communication needs to be broken since that will now be routed through the computer sequencer. So into System, MIDI, look for the local switch and turn that off. Okay, well, without the computer plugged in, there will no longer be any sound generated when you play the keyboard. That's fine. Now, both of those bits of software I mentioned contain patch librarians, and in the librarian you will be asked for bank select messages to be input. Now obviously the XP-80 contains much more than 128 patches, so simple MIDI program change commands from the computer will not be enough to access the sounds. If you go to the sound list in patch mode, you'll see at the bottom bank select MSB and LSB. Well, these 2 MIDI messages need to be input into your patch librarian within the software you happen to be using. Then, from the display, you can call up the relevant patches. You don't have to turn to the XP-80 at all. Well, that's just about all we've got time for. The XP-80 is a truly wonderful, powerful music production tool, and I hope you have a lot of fun producing music with it. So until next time, goodbye.